Hi everybody, I'm in lesson 9.4 about inscribed polygons. Yesterday we got halfway through the lesson and we stopped when we got to the constructions. Right now I'm going to show you how to do those constructions. So we're going to move into this lesson in the packet. The first construction that we're going to start with is construct a rectangle inscribed in a given circle. Explain how the properties of a rectangle are demonstrated in your construction. So we're actually going to use the properties of a rectangle to do this construction. The two properties that we're going to use about a rectangle are diagonals, congruent, and four congruent right angles. If you know these two properties of a rectangle, then we can do this construction. So the first thing that you want to do is go ahead and draw one of those diagonals. Now the diagonal of the rectangle is actually going to be a diameter for the circle. Okay, when you draw a diameter, what you're doing is you're making a semicircle. You're also getting a diagonal for your rectangle. The second part of this construction, you have to remember something off of our reference sheet. An angle inscribed in a semicircle will be a right angle. So what we're going to do is make this right angle. That's going to be one of the right angles for my rectangle. So we're going to take my semicircle and we're going to put a vertex somewhere along the arc of the semicircle. Now you're going to draw an inscribed angle going to that vertex point. Basically what we just did is half of the rectangle. To finish the construction of the inscribed rectangle, you're going to draw your other diagonal, which will be congruent because it's going to be another diameter of the circle. So from this vertex through the center point, we're going to have our other diameter, and that diameter is the other diagonal. Okay, now you're going to connect all four. So this angle is definitely a right angle because it was inscribed in a semicircle. Diagonals are congruent. Please raise your hand in class if you have a question about this construction. Now I'm going to show you how to construct a square. Construct a square inscribed in the given circle. Explain how the properties of a square are demonstrated in your construction. The two properties that we're going to use to construct the square are diagonals congruent, which comes from a rectangle, and diagonals perpendicular, which comes from the rhombus, and lastly, diagonals bisect each other, which comes from the parallelogram. So a square is a rectangle, a rhombus, and a parallelogram. So we're going to show all three of these in our construction. The first step to constructing a square, you're going to draw a diameter in the circle. And just like before, this diagonal is going to be, this diameter is going to be the diagonal of our square. Now, instead of just go ahead and drawing the other one, we have to make sure the other diagonal is perpendicular and it bisects this one. That should make you think of our perpendicular bisector construction. So grab your compass, put your compass on one end of this diameter, go a little bit more than halfway, make your first arc, go to the other end of your diameter. That is my perpendicular bisector construction. Now I can go ahead and draw the other diagonal. So those two diagonals are perpendicular and they cut each other in half. So here's where your square comes in. Your square is going to be on the four corners of those diagonals. Connect with a straight line. That is how you construct a square inscribed in a circle. Alright, now you should try the square on your own. Give you a couple of minutes to do that. You can pause the video. And then also think about how can you construct an octagon inscribed in the circle. How is an octagon related to a square? So an octagon has a regular octagon has 8 congruent sides. So how can we go from a 4-sided square to an 8-sided octagon? Give that one a try. The next one I'm actually going to show you is the regular hexagon. Okay, construct a regular hexagon inscribed in the given circle. Note, a regular hexagon can be built from 6 equilateral triangles. Okay, so what we're going to do is we're going to use a radius. Okay, the radius, if we keep copying the radius 6 times, you're going to get these 6 equilateral triangles, and then we're going to get the hexagon. So the first step in constructing the hexagon is to make any point on the circle. Okay, now we're going to draw that radius that's going to be one of these lines for those equilateral triangles. Okay, now you're going to take your compass and you're going to measure that radius. And what we're going to do is off of that point that you made, we're going to put a little hash mark on the circle. Then jump to that mark. Put another one. Then jump again. We're going to do this all the way around the circle. 1, 2, 3, 4, 5, 6. At those marks are the 6 vertices for my hexagon. So you're going to take your straight edge and you can now draw the sides of the regular hexagon. Remember, regular means all sides are congruent, so that's what's going to happen in this construction. That's how you construct the regular hexagon. Now, to construct an equilateral triangle inscribed in the circle, we're going to do the same thing that we just did, but instead of connecting all 6 vertices around, we're gonna skip and do every other. So we're only gonna connect 3 of those hash marks to make the equilateral triangle. So start with any point on your circle. Draw in a radius. Okay, measure your radius. Okay, and now off of that vertex, you're going to kind of do like a windmill. Around 6 times. Once. 2, 3, 4, 5, 6, and you should end up back where you started. Now to make the equilateral triangle, you're going to skip every other hash mark. So we're going to use the original vertex that we had, skip 1, we're going to use this guy over here, skip 1, and this vertex down there. So if you connect those 3 vertices, you're going to have an equilateral triangle. That would be the most efficient way to construct an equilateral triangle. Kind of interesting, again, that there are really 6 of these little guys in the regular hexagon. So if you drew all of your radii here, you're going to see all 6 of those equilateral triangles. All radii in a circle are congruent. So that's why all of these triangles are equilateral. All of these radii are congruent. And since it's a regular hexagon, all sides are congruent for this hexagon. So give these a try. Raise your hand if you get to a point where you have a question, or you can rewind as many times as you need to. And then when you're done with these constructions, please come see me so you can work on some angles practice. You're going to have a practice page over the weekend that has all of these angles in a circle. All right, cool. Thank you.